today I will explain what our project is and how it came to be. This project came to be when we decided to have an easier and more accessible way for people to explore the waters. We first embarked on creating a micro AV that making it be able to collect data and move automatically in the ocean. To make this reality happen, we decided to make the drone more economically viable, so more people have access to it. Our goal was the more people that have access to it, the more the drive for water exploration will be.
There were three main factors that were considered to the concept development of our micro AUV, those being power, communication, and computation. For power, we decided to use a LiPo battery to power our main thrusters, and to power our Raspberry Pi 4, we decided to use a power bank. For communication, we decided to use a Wi-Fi instead of Bluetooth due to its faster connectivity and better range. For computation, we decided to use a Raspberry Pi 7 NVIDIA Jetson or an Arduino due to its size, its relatively low price compared to an NVIDIA Jetson, and its power consumption compared to an NVIDIA Jetson as well. We also decided to use a Pi 4B due to its more RAM, so we can have more computational power for its temperature sensor and pressure sensor.
For the end product development, we have three main internal components. We have the Raspberry Pi, we have the power bank, and we have the LiPo batteries. As we know, the thrusters have an ESC, or electronic speed controller, that goes inside the casing into the electronics tray and connected to the Raspberry Pi. The Raspberry Pi is powered by a USB Type-C cable coming out of the power bank, and the LiPo batteries power the thrusters. We also have the camera in the front that connects into the Raspberry Pi slot, allowing us to take pictures and footage, and as well as the cable management here for the sensors that connect into the Raspberry Pi. Overall, we went to that design to make the micro AV low cost and efficient machine.
For our end product development, these are the outside parts we went with and what we used for the final AUV design. So as you can see, we have our two clamps right here, and they're connected to the casing, which is made out of acrylic glass, as well as the end cap. They're both transparent, so we can see if there's water leaking in, and also for the end cap here, so the camera can see outside to see the environment and see what may be going on, if there's something going wrong in the water or not. And we also have our 3D printed end cap here, which is made out of PETG, which makes it a lot stronger and has 5 holes in it, so we can fit all the sensors and cables inside of the casing. And we also have our other 3D printed parts, like a bridge connector and clamps, to have our thrusters on the outside as well. Here we have the AUV looking around the ocean. As you can see, it shows the temperature in Celsius, the angle and direction it's heading in, and also what position the camera's in, and the depth it is currently at. Right now it is scanning for coral reefs and it's moving around, and its max depth it can go to is 10 meters, which is roughly about 30 feet.